Right, ready. So here we are going to discuss about a Bloch sphere and how to get the state corresponding to a point on the Bloch sphere, because the point on the Bloch sphere always represent the state of a qubit. Okay, so let me take this qubit representation. Qubit representation on Bloch sphere. So earlier you asked me, sir, how we have written that state cos theta by 2 ket 0. You asked this. That is what we are going to do today. Why we got theta by 2? This is your question, right? Right. So here I have a Bloch sphere. Now this is y-axis and this is the x-axis, usual 3-dimension z. Now what they are saying is, if you take a point on the Bloch sphere, so this is the state psi, which is making an angle theta, and its a projection is making an angle phi with respect to x, and this state psi is nothing but cos theta by 2 ket 0 plus e raised to I phi sin theta by 2 ket 1. And sometimes we will take the global phase for this state, e raised to I gamma. So this is nothing but a global phase. We already discussed earlier in our classes, the global phase is not having any significant change, because the unitary operator, whatever we are operating is unitary operator. So once you operate the unitary operator on this side e raised to I gamma will be there. In the bracket bra side e raised to minus I gamma will be there. Both will be cancelled. That's why there will be no significance for this global phase. You understand, sir? What I am saying is, when you operate u e raised to I gamma some state psi, okay, and this is the ket. And again if you operate here e raised to I gamma psi on bra side, this will be e raised to I gamma, this will be e raised to minus I gamma, and again it become psi u psi. That's why this is always becoming 1. So that's why there is no significance for the global phase for the unitary operations. Right, good. So that's why we are not taking this, sir. Finally our state is cos theta by 2 ket 0 plus e raised to I phi sin theta by 2 ket 1. Now the question is, how we got this? Theta by 2. Right. Cos theta by 2 ket 0 plus e raised to I phi sin theta by 2 ket 1. Actually derivation undi. I mean they are not giving in the books actually. Quantum computation is what they are doing is, whatever required for computation they are taking, but this origin is in the quantum mechanics. That is what I am going to explain today. Right. So first let me go to this spin angular momentum. Little bit quantum mechanics we need here. Spin angular momentum. I won't discuss very complicated things. So spin angular momentum. Right. Sorry? Omega na. Nothing. Mere tension madakandi. Right. So this is as usual. I am taking x-axis, y-axis and z-axis. I have a spin angular momentum vector. Actually, so this spin angular momentum vector is precessing about the z-axis generally in a hydrogen atom or something like that. Right. Now what I am taking is, if I measure s bar along y-axis, could you please tell me what I measured? Sy. If I measure s, I mean spin angular momentum of the particle along the z-axis, what I will get? Here along x-axis, x. Actually this Sy can be written as, yesterday also I told you in the earlier classes, S bar dot y cap. This Sx is nothing but S bar dot x cap, because S bar contains Sx, Sy, Sj. Once you make the dot product with the x cap, only Sx remains, remaining all zeros. Similarly, S bar dot z cap. Is that clear, sir?
Yes, sir.
Right.
So, basically you are trying to recollect the equation A bar is equal to Ax into x cap plus Ay
Yes.
y cap plus Az into z cap.
Yes, sir. Yes, sir. Yes, sir.
Okay.
Right. Fine. Okay. So now first we have to know few things. Here we got Sx, Sy, Sz. What are Sx, Sy, Sz? The measurement operators corresponding to the spin measurement along x, y, z. Is that clear? Right. Now I hope you remember, I think Sx is somewhere you have seen. What is the matrix corresponding to Sx? H cross by 2 Pauli matrix. Sy is nothing but H cross by 2 Pauli matrix, sigma y. Sz is nothing but H cross by 2 Pauli matrix, sigma z. Okay, sir? Right. Now let me write Sx first. H cross by 2, sigma x, 0, 1, 1, 0. Sy, H cross by 2, sigma y, 0 minus I, 0. Sz, H cross by 2, 1, 0, 0, minus 1. Now, what are the eigenvalues? Eigenvalues of sigma x, eigenvalues of sigma y, eigenvalues of sigma z, all are same. Eigenvalues. Eigenvalues. So, for example, I have taken 1, 0, 0, minus 1. Is it a diagonal matrix? That's why eigenvalues are what? Simply lambda equal to 1 comma minus 1. Similarly, if you take sigma x, that is a 0, 1, 1, 0. Do you know how to find the eigenvalues of a 2 by 2 matrix, sir? Lambda square minus trace lambda plus a determinant equal to 0. No problem. If you don't know, I think you know this. A minus lambda I determinant equal to 0. This and this both are same. Okay. So that's why after actually simplifying you will get this only, sir. Lambda square minus what is the trace? 0 plus determinant 0 minus 1. That's why minus 1 equal to 0. Finally, lambda square equal to 1, lambda equal to plus or minus 1. So finally, all sigma x eigenvalues are plus or minus 1, plus or minus 1, plus or minus 1. Is it okay, sir? Now,
Sir, can you do it for y, sir?
yeah, why not? Why not? Right, sigma y. No problem. 0 minus I 0. Tell me what is the eigenvalue equation? Lambda square minus trace lambda plus determinant equal. Right. Now tell me. Lambda square. What is the trace? 0. Now what is the determinant? 0. Minus
into minus I. So that will be plus 1.
No. 1 minus is there. That minus and this minus gone. Iota into iota, one more minus come. Equal to 0. That's why lambda square equal to 1. So implies lambda equal to plus or minus 1.
Lambda square minus trace lambda plus determinant is equal to 0. This will make it more easy, sir. Than a minus lambda ఇదంతా చెత్తగా
అంటే 2/2కి ఈజీగా ఉంటుంది, బట్ 3/3 కొంచెం లిటిల్ బిట్ కాంప్లికేట్. 2/2 బెటర్ టు గో విత్ లాంబ్డా స్క్వేర్ మైనస్ ట్రేస్ లాంబ్డా ప్లస్ డిటర్మినెంట్ ఈక్వల్ టు 0. Yes sir, yes sir, right sir. Okay, so we got the eigenvalues of sigma x, sigma y, sigma z, but we want the eigenvalues of Sx. That's why simply multiply with whatever the constant you have into h cross by 2, that's it, into h cross by 2 into h cross by 2. So finally we have eigenvalues of Sx, Sy, Sz. Sir, please don't forget this. Sx is nothing but s bar dot x cap, Sy is nothing but s bar dot y cap, Sz is s bar dot z cap. Sir, see, what are the eigenvalues you got? H cross by 2 into plus or minus 1. I think I can take it as a plus or minus h cross by 2.
Yes, sir.
Right, wait. Observe. Along x-axis you measure, you got the eigenvalues. Along y-axis also measured, same eigenvalue. Along z-axis also measured, same eigenvalue. What does it mean? Eigenvalues independent of arbitrary direction. Arbitrary direction means unit vector. X cap, y cap, z cap. So if I take eigenvalues of, this is important sir, if I find eigenvalues of measurement s bar dot n cap, see, x cap no change, y cap no change, z cap no change. That's why an arbitrary unit vector, for this also eigenvalues must be plus or minus h cross by 2. By taking analogy, we have written that. Is it okay? Right. Right, sir. Next, sir, its eigenvalues part is clear. We should know about eigenvectors. Directly going to the general one, let me find the eigenvectors of any one thing. You please choose any one. I will explain the eigenvectors. Sx, Sy, Sz. Your wish.
X.
Right. So we are finding the eigenvectors of Sx. These are called diagonal bases in our computational. Right. If you choose Sz, those are called computational bases. Ready, sir? Right. So if you want to find eigenvectors, this is the eigenvalue equation. A cap psi equal to lambda psi. Okay. Psi I don't know, but lambda I know. Lambda equal to, first I am taking plus h cross by 2. Okay. What is my operator here? You have chosen Sx. I hope Sx you remember, h cross by 2 into sigma x, 0, 1, 1, 0. Yeah, psi I don't know, let it be xy. Lambda I know, plus h cross by 2. Psi as it is xy. Okay, sir? Is it okay? A I substituted Sx, this is Sx. Psi I don't know, lambda I know. I am finding the eigenvector corresponding to plus h cross by 2. Now h cross by 2 cancel. Rho ket 0 into x plus 1 into y, 0 plus y equal to x. That's it. So you got the condition x equal to y or y equal to x. Is it okay? Right. Now you are going to write the eigenvector. Remember one thing. Eigenvectors, infinite eigenvectors exist, sir. Because if I say 1, 1 is the eigenvector, 2, 2 is also eigenvector. -2 is also eigenvector. Like this, so many eigenvectors will be there. But which one we have to take it as a standard? The least one. Okay. So finally I am writing my psi. I have assumed psi as xy. Okay, please keep this x as it is. Now what is your y? Already you got one equation, y equal to how much?
X.
Keep it x. Oh, so this is the general form of eigenvector corresponding to this eigenvalue x, this eigenvalue. Now there are so many things are there, 1 1 2 2 3 3 4 4, all are correct, but which one we will take? The least one. I said least one. Least one is what? 1 1. And it's a normalization constant. I told you earlier, normalization constant is 1 over under root a square plus b square, mod a square plus mod b square. How much? 1 by root. I hope if you remember, this is our diagonal basis plus. So, right. This is the diagonal basis plus 1 1. Now I request you please find for lambda equal to minus h cross by 2. Yes, proceed. Sx psi equal to lambda psi.
So psi here is Sx, sir?
No, a is Sx. Psi we don't know. Let it be xy.
Finding psi. Okay. Sx psi is equal to lambda psi. Lambda is equal to minus h bar by 2. So Sx is equal to minus h bar by 2. 2 0 1 1 0 1. X y is equal to minus h bar by 2. XY. These guys got cancelled. So 0 plus y is equal to minus x. Y is equal to minus x.
That's it.
1 minus 1.
That's it.
Lowest value.
Normalization constant 1 by root. So this is nothing but our minus represent minus eigenvalue, okay, negative eigenvalue. So what is this state? 1 by root 2 1 minus 1. Right, fine. Like this we can find for sy basis or as well as sz basis. Okay, so from here only we got that basis. Computational basis are nothing but the sz basis, and diagonal basis are nothing but the either x or y, both called diagonal basis. Okay, sir? Right.
So I'll calculate for y and z.
Try, yes. Proceed for z, because y we won't use. Y we won't use, z you please find. Okay, right. Sir?
You want me to do it now?
Your wish.
No, we'll proceed. I'll do it as a homework.
Right, sir. Right. So that is nothing but a computational basis. Then you will get an idea how we got this 0, 1, 1, 0. Those are nothing but the eigenstates of Sz. I hope got it. Okay. Now I am coming to the arbitrary direction. Because you are representing the qubit point on the Bloch sphere anywhere now, not along x-axis, not along y-axis, not along z-axis. I hope if you understand, if you take a Bloch sphere, this is the y-axis and this is the x-axis, this is the z-axis. If you find the basis of z, the points lying on the z-axis which are intersecting the Bloch sphere, this we call it as a 0, this we call it as a 1. These two are the eigenstates of Sz. Similarly, if you see the textbooks somewhere, what they will do is, they will take one plane like this and they will show here, and they will take this point as a plus and this point as a minus. Means this plus is nothing but this one, which is the eigenstate of Sx measurement. This is the eigenstate of Sx measurement. Am I right? Right. Now we are talking about more general. So that's why I have to take the spin vector neither along x, y, z, some arbitrary direction. Now I am going to measure not along x axis, not along y axis, not along z axis. An arbitrary direction. Arbitrary direction is what? N cap. I hope you remember n cap in the earlier classes I explained. N cap is nothing but r cap. Okay. That n cap, if you remember, we have written sine theta cos phi. You remember, sir?
Yes, sir.
Comma sine theta cos sine phi, comma cos theta. Sine phi, comma cos theta. Okay, I will write in order. Right. So this n cap is nothing but sine theta cos phi, sine theta sine phi.
ఈ రెండు ప్రొజెక్షన్ సంబంధించినవి సార్. ఆ cos theta ఒకటే పైన కూర్చుంది.
Now
మీరు డ్రాప్ చేశారా sin phi అక్కడ ఆ ప్రొజెక్షన్ కి sin
ఇది
డ్రాప్ చేశారు.
ఇదా మీరు అన్నది? Okay. Okay. Right. Now I am going to measure spin in arbitrary direction. In arbitrary direction. Now see, sir, if you measure the spin along x-axis, what I said, s bar dot x cap. Along y direction,
S bar dot y cap.
along arbitrary direction,
It will be whatever it is n cap.
s bar dot n cap. Am I right? Now I have to get that matrix first. That means operator. I have to get the operator corresponding to s bar dot n cap. Sir, earlier why didn't you get? We have written Sx, Sy, Sz matrix. Now similarly s bar dot n cap means Sx, sir, dot product, Sx into sin theta cos phi plus Sy sin theta sin phi plus Sz cos theta. Okay. Now let me write. I think Sx matrix you know. So that is H cross by 2. H cross by 2. I am writing this. Here 0. Here 0. Here 1 is there. 1 into this is nothing but sin theta cos phi. Is it okay? If it is fast, please tell me.
Yes, sir. We are going a little fast.
Oh no. Okay.
Okay, ఒక్క నిమిషం సార్. S6
You understand this dot product?
Yes, sir.
Because S bar is nothing but Sx, Sy, Sz. Simply dot product. First into first, second into second, third into third. Now what I am saying is just write this matrix. H cross by 2 outside. What is Sx matrix? And sigma x or x matrix.
0 1 1 0.
You are multiplying that 0 1 1 0 with this. Tell me what you will get. Okay. Okay, no problem. I will write like this. I understand. I will write like this. Wait. H cross by 2. Now this is y matrix, Pauli matrix. Tell me.
0 minus I 0
Into.
sin theta sin phi.
That's it. Plus H cross by 2. Sz.
Sz అంటే 1 0 0 minus 1.
That's it. Into.
2 cos theta.
Ante. Now it's just a multiplication. So this will take and multiply with each and every element. Now H cross by 2 0 sin theta cos phi.
Sin theta cos phi.
That's it.
0
That's it.
plus.
I am not writing h cross by 2. I am taking common.
Okay. So sin theta 0 minus sin theta sin phi.
Minus iota sin theta sin phi.
I sin theta sin phi 0 plus cos theta 0 0 minus cos theta.
That's it. And overall h cross by 2 outside. Now h cross by 2. I am adding the matrices. Not at all difficult. Adding the matrices. 0 plus 0 plus cos theta.
Cos theta.
Next, sin theta cos phi minus I sin theta cos phi 0.
Sin theta cos phi minus I sin theta cos phi.
With your permission, I will take common sin theta.
Okay. Cos phi minus I sin phi.
That's good. Next, here also please take common sin theta.
Sin theta into cos phi plus I sin phi. E to the power y theta తీసుకొస్తున్నారా? Okay. Alright sir. Okay. 0. So ఇక్కడ ఏం కామన్ తీయలేం సార్ మనం.
యాడ్ చేసేయండి.
Okay. Minus I sin theta.
No. 0, 0.
Okay. I'm sorry. Minus cos theta. Yeah.
So finally, I got the matrix corresponding to arbitrary measurement h cross by 2, cos theta as it is, this is sin theta as it is, but this can be written as e to the power of minus I phi sin theta, and this can be written as e raised to I phi sin theta cos phi, cos theta. Clear, sir? Now I got the matrix corresponding to arbitrary, because earlier I find the eigenvalues of Sx, I got the Sx basis. If I find the eigenvectors along z axis, I will get the computational basis. Now we want to represent more general state, that is any point on the Bloch sphere. That's why we measure the spin in arbitrary direction, that is nothing but s bar dot n cap. So for this matrix we are going to find the eigenvectors. So s bar dot n cap, I got h cross by 2. Once again I am writing the matrix cos theta e raised to minus I phi sin theta e raised to I phi sin theta cos theta. Now sir, once again, earlier we find the eigenvectors for Sx, then we got x basis, then next we find the eigenvectors of Sy, we will get the y basis. But here we want to get the arbitrary, that's why I have taken arbitrary measurement. Is it okay?
Yes, sir.
Right. Now let me write the eigenvalues. Eigenvalues I told you, Sx, Sy, Sz, arbitrary direction, eigenvalues won't change, same.
H by 2. H bar by 2.
Right. Now I will explain one, second one you please try.
Yes, sir.
Now please listen. Lambda equal to plus h cross by 2. For this eigenvalue, I am going to find the eigenvector a psi equal to lambda psi. This is called eigenvalue equation.
Yes, sir.
Operator, eigenstate, lambda. So operator already I have h cross by 2. In the place of a, operator cos theta e raised to minus I phi sin theta e raised to I phi sin theta cos theta into psi xy lambda h cross by 2 xy. Is it okay, sir?
Yes, sir.
Now h cross by 2 cancel. Now multiply row with column.
X cos theta plus e to the power of minus I phi sin
Why? Why? So e raised to minus I phi sin theta y equal to x. Because row into column equal to this first one. Right. Now, వద్దండి ఆపండి ఒక్కటి చాలు. ఎప్పుడైనా 2/2లో వన్ ఈక్వేషన్ ఈజ్ ఎనఫ్. ఓన్లీ జెడ్ మ్యాట్రిక్స్ వీ హ్యావ్ టు టేక్ బోత్. Right. Okay, fine, and we got this. So I told you first always find y. That means y e raised to minus I phi sin theta equal to x common. Okay. Right, fine. Now in the last class we have discussed 1 minus cos theta is nothing but what? Sin square theta by 2. Sin theta is what?
2 sin theta cos theta, sir.
No. Theta by 2.
Okay.
Cos theta by 2. Now please cancel. Here sin theta by 2. Here sin square theta by 2. Square cancel.
1 second, sir. I'm slowing down just to analyze it.
Okay.
2 sin theta by 2 cos theta by 2 కింద రాసుకుంటే x into 1 minus sin square theta by 2.
No. 1 minus cos theta is sin square theta by 2. Total 1 minus cos theta.
Sin square theta by 2. Okay. వీడు లేచిపోయాడు. Okay. So y into sorry, 2y
2y.
e to the power of minus I phi cos theta.
1 minute. Sir, 1 minus cos theta, here also 2 will be there. నిన్న క్లాస్లో అనుకుంటా చెప్పుకున్నాం ఎస్టర్డే.
2x అవుతుంది. 2x sin square theta by 2, so sin లేచిపోతాయి. 2 లేచిపోతాయి.
Right.
So y into e to the power of minus I phi cos theta by 2
Correct.
is equal to sin theta by 2.
X into sin theta by 2. Okay, sir?
Yes, sir.
Right, fine. So finally we got y into e raised to minus I phi. Just I am writing whatever I got. This is x into sin theta by 2. Okay? Right, sir? Ready, sir? Right. So I told you always find y. Then bring these two terms that side. Then sin theta by 2 by cos theta by 2. Okay? You are bringing this e raised to minus I phi that side. Is it okay?
Yes, sir.
E raised to minus I phi, you bring this side into x. Now see. Now we are going to write the matrix. We got the y. Earlier also, if you remember, once we got the y value, we have written the matrix. I mean, we have written the vectors, eigenvector. Now, what is my eigenvector? X, y. X I will keep it as it is, and I will write my y. Y sin theta by 2 by, I am writing y cos theta by 2 e raised to I phi into x. Now least one we have to take. That's why 1 sin theta by 2 by cos theta by 2 e raised to I phi. Up to this is okay? Right. Next point. అదే చెప్తున్నాను. Listen. Whenever we have fractions in the eigenvector, for example, we have eigenvector by mistake like this 1 1 by 2. We should not keep eigenvector in the fractions. So what to do? Whenever you have a fraction, you just multiply. Here the denominator is 2 into 2 into 2. That's why it becomes 2 1. Because if any eigenvector is multiplied with any integer, again it is also an eigenvector. That's why we have to make it free from fractions. One more example. If you have 1 by 3 2, we should not keep it as it is. We have to remove this 3. That means you are multiplying 3 here and 3 here. That's why, that's it. So if you take tan theta, that is also a fraction. That's why we are not taking that. Right. Now, sir, we have to multiply with what? Please tell me.
Cos theta by 2.
That's it. Cos theta by 2. Here cos theta by 2 cancel. Sin theta by 2 remain. Into one more is remain. E raised to I5. Your answer is ready. So this is the eigenvector corresponding to plus h cross by 2. Am I right? Now write this. This is a vector. Write in the linear combination. Linear combination means this, for example, 1 2 you have. How you will write a vector? 1 I cap plus 2 j cap. But in our quantum mechanics, what are the basis states? 0 1. Now tell me, sir, cos theta by 2 get 0.
Plus sin e to the power of I5 sin theta by 2 get 1.
That's it. This is the qubit state on the Bloch sphere.
For an arbitrary state.
Yes, anywhere, any point. If you just change the theta and phi values, you will get the points on the Bloch sphere.
In the Bloch sphere or on
No, on the Bloch sphere, on the Bloch sphere. Because it is a unit magnitude is 1. So similarly, if you go for minus h cross by 2, here you will get e raised to minus I5. మీరు ప్రాక్టీస్ చేస్తే బెస్ట్. సిమిలర్గా ఉందిగా ఇప్పుడే చేసేయండి. మళ్ళీ హోంవర్క్ అంటే ఎక్కువ అయిపోతాయి. Yes, sir. Minus ఇక్కడ minus. Here minus. I5 as it is, here minus e raised to I5. I think you will get e raised to minus I5. Y sin theta e raised to minus I5. Okay. Kanin, proceed. Correct. ఇక్కడ ఓన్లీ మైనస్ x వచ్చిందా హియర్? That's good. Proceed. You are the right track. ఈ స్టెప్ ఉంచిందా, దిస్ వన్ విత్ మైనస్ హియర్. ఇక్కడ x minus here. After cancellation, please say that step. మరి ఇక్కడ మైనస్ ఉంది కదా, హియర్ మైనస్ అవుట్ సైడ్, అప్పుడు మైనస్ ఎక్స్ హియర్. అయ్యో నో నో నో, ఓన్లీ ఐగన్ వాల్యూ మైనస్, అది మ్యాట్రిక్స్ యాజ్ ఇట్ ఈజ్. Matrix is as it is, only eigenvalue we are changing. Okay. అంతే. Here only here this plus will be changed to minus, plus or minus, అంతే, that's it. Yeah, here also I think you have taken minus here. Okay. So here we got the Bloch sphere and an arbitrary state. Here a small point is there, then we will stop. This is the psi, okay, this is the theta and a projection, okay, and this is angle phi. Now see sir, and here I am taking psi plus. What is the meaning of psi plus? I have taken plus eigenvalue. I think we got cos theta by 2 ket 0 plus e raised to I phi sin theta by 2 ket 1. Now what I am going to do is, I am going to take exactly opposite point. Exactly opposite point. Are you observing? How to get the exactly opposite point? If I turn like this, that is a pi, but I have to subtract theta. So theta is replaced with pi minus theta. Okay. I want this exactly opposite point. Okay. What is the exact opposite point to Z? This one. But I want this side theta. That's why I have to go this side theta. Then I have to subtract theta, na? You are adding here theta. So I want to get back. That means this opposite, get back. That means what? I have to subtract theta, na?
Yes.
So that means this point will be obtained from theta is replaced with pi minus theta. Similarly, this point is obtained from phi is replaced with pi plus phi. Because this projection I have to take exactly opposite. Okay. Now I have to take like this projection, but this is the pi, but I already have an extra angle. How much?
Phi.
So that means for phi I have to add phi and I have to subtract theta here. Simple logic I will tell you, maybe you will get confusion. Sir, theta is a clock or anti-clock?
Clock.
Phi is clock or anti-clock?
Anti.
Anti-clock always take plus, clock always take minus.
Okay.
Because anti-clock measurements are positive angles, clockwise measurement angles are negative. Like that we can take. So that's the logic. Okay. So here phi is replaced with pi plus phi. Now see the magic. Cos theta I am replacing pi minus theta by 2 ket 0 e raised to I. Phi I am replacing phi plus pi pi plus phi, sine theta replacing pi minus theta by 2 ket 1. Okay, sir? Now, sir, cos 90 minus theta by 2. This is pi by 2 is 90.
Yeah.
Cos 90 minus theta by 2 is nothing but sin theta by 2.
Theta by 2. Yeah.
Okay. So, sin theta by 2, 0. I don't know why you didn't get this earlier here. You should get a reverse also. I mean, this sin theta by 2, cos theta by 2 also should be reversed. ఏండొచ్చు ఎక్కడన్నా మళ్ళీ ఇంకోసారి ట్రై చేయండి. యాక్చువల్గా ఏముందంటే ఇక్కడ మైనస్ వస్తుంది. ఈ కాస్ థీటా బై 2 రీప్లేస్డ్ విత్ సైన్ థీటా బై 2, సైన్ థీటా బై 2 రీప్లేస్డ్ విత్ కాస్ థీటా బై 2. అయ్యుండొచ్చు. ఒక్కసారి మళ్ళీ ట్రై చేయండి. కెట్ 0 ప్లస్ సార్ ఇది చూడండి. దిస్ ఈజ్ e raised to I pi plus phi. Shall I write like this? What is e raised to I pi? Minus 1. Yes, minus. So, e raised to I phi as it is. Sin 90 minus theta by 2. Sin 90 minus theta by 2. Sin 90 minus theta by 2 is nothing but what? Cos theta by 2. So, this is, you must get psi minus actually. So, what they are saying is, if you find the eigenvector, one eigenvector, exactly opposite point is also another eigenvector. So, that's why in the z basis, we will take like this. This is the point ket 0, quite opposite what you have taken, ket 1. So, opposite points on the Bloch sphere represent the eigenstates. So, this is a quite opposite points. Two opposite points
on the same plane.
On the Bloch sphere represent basis. Basis states. If you take along x-axis, you will get x basis. If you take along z-axis, you will get z basis. That's it. I think after this, our videos, I mean earlier videos, if you watch, you will get that gates, sir. Because this one I didn't explain in that videos. How we got that state, we didn't explain. And one more derivation I didn't explain. We have written single qubit gate. Some expression we have written, after that theta, everything you substituted. That I will explain. Don't worry. So this is enough for today, sir. So please practice this and we will enter into gates next.
Okay, sir. Okay.
Right.
Okay, so నేను తర్వాత ఇంక మీరు బేస్ చేయకర్ లేకుండా అది నంబర్ మార్చేసుకుంటే సరిపోతుందా సార్?
అంతే. ఎస్టర్డే 4 కదా, ఈరోజు 5.
5 6 రెండు అవుతాయేమో.
రైట్ 5 6 ఎస్ ఎగ్జాక్ట్లీ. అప్లోడ్ చేస్తాను సార్. రైట్ సార్. రైట్ సార్, థ్యాంక్ యూ. గుడ్ నైట్ సార్.